one more problem, that is, this is the circuit, and this circuit is also not very complicated. It's a kind of very simple circuit, RLC series circuit. And here we have the two capacitors. You can see here, this capacitor has a 20 volt and this capacitor has 10 volt, and this is 3 farad and this is 6 farad. There are some complications that you have to solve and find, or you have to apply the Laplace transform to analyze this circuit. What is the question? In the following circuit, the switch is closed at t equal to 0. So 3F and 6F capacitors are initially charged to 20 volt and 10 volt respectively. So remember here, so far we assumed always initial voltage as 0. Here we have the initial voltage. So initial voltage is 10 volt here and 20 volt here in this capacitor. And find the current I of t in this circuit and draw the circuit in S domain. So the problem looks little bit simple, but it has quite some information inside. So you have to read the question properly and understand the problem first. Then you can go to the solution. So this is the circuit, and now you have to write the KVL, and the KVL will become like this. So we are assuming all the voltage drops is equal to 0. So here 1 divided by C1 integral of minus infinity to t I of t dt, and this is the R1, this is R2. Here also you can see two resistors. It's not just one resistor, we have two resistors and two capacitors. So R1 is 1 ohm, R2 is also 1 ohm. So R1 times I of t, R2 times I of t, because the same current is flowing. And 1 divided by C2, C1 is 3 farad and C2 is 6 farad. So 1 divided by C2 times integral of minus infinity to t I of t dt equal to 0. So this is the time domain equation. So now we can apply the value whatever we have. C1 is equal to 3F, C2 is equal to 6F. This is C2. And this is C1. And this is R1. And this is R2. So apply these values in this equation, then the equation will become like this. So here you can see R value, R1 is 1 ohm and then R2 is 1 ohm. So 1, 1. So you can add this together, that becomes 2 times I of t. And here the equation is same. And the initial voltage is minus 20 volt here. And here we have 10 volt, plus 10 volt. So then you can simplify this equation further down. Then this equation will be like this in time domain, and you can convert this into S domain. So this is nothing but this 1 divided by CS. C value is 3 farad, so that is becoming 1 divided by 3S I of S plus 2 times I of S, that is the resistor, and the another capacitor, that is 1 divided by 6S times I of S, and minus 20 divided by S plus 10 divided by S. So this will become minus 10 divided by S, because this is using the same numerator and denominator. So we can simplify this further down. So the same equation will become like this. So this minus 10 divided by S, you can take it to the right side. You can take this I of S as a common. So 1 divided by 3S plus 1 divided by 6S. Again, this one you can simplify. So if you take 6S as a common, then this will become 2, and this 1 is as it is. So this is 3 divided by 6S. So this 3 and this 6, it will become 2. So this becomes 1 divided by 2S. So that is what I have written here. I of S times 1 divided by 2S plus 2 times I of S. This is the resistor, the current across the resistor, and equal to 10 divided by S. So again, you can take the I of S as a common. So then this will become 1 divided by 2s plus 2. So again, I take the 2s as a common, then it will become like this, 1 plus 4s, the top or in the numerator. So I can simplify this further down. So I of s is equal to, I bring this term to this right side, then this 2s go to the numerator, and then this 1 plus 4s will become denominator. So the s and s got cancelled, and this 10 times 2 is 20 divided by 1 plus 4s, or 4s plus 1, I can write it. So now this is the final equation of the current. And of course, this is 4s plus 1. I don't want this because I have the formula only for s plus a. So I have to make this a 4s as a s. For that, I need to divide the numerator and denominator by 4. So I can divide here. Then this 20 divided by 4 becomes 5. 4s divided by 4 is s. 1 divided by 4 is equal to 0.25. So now I got the equation like 1 divided by a plus a, this format. 5 is a constant, just forget that. So this is the final equation of the current of this circuit in Laplace domain. And now I have to do the inverse Laplace transform. So I apply the inverse Laplace transform. Now this becomes I of t is equal to, so 1 divided by s plus a, the formula is e to the power minus at. So a is 0.25 here. So 5 is a constant, keep it outside, and e to the power minus a, so minus 0.25 t. So this is the final equation of the current in time domain. So now you have time domain and you have the s domain. Sorry, this is the s domain and this is the time domain equation. So this is what asked in the question, I think. Find the current I of t in the circuit and draw the circuit in S domain. So now we have also another part of the question is draw the circuit in S domain. So the same circuit you can draw. So R is the same. I'm just writing that instead of 2 times, I'm writing only 1, and then I'm adding because the 2 resistors are in series. So you can write 1 plus 1 as a 2. So 2 ohms R, and the capacitor is 1 divided by 6s because it's a 6 farad, and the formula is 1 by 1 divided by cs. So here I had written, so 1 divided by 6s, and here it becomes 1 divided by 3s because the capacitor value is 3 farad, and the initial voltage is plus minus the same polarity, and this is the 20 divided by s because this is v of 0 minus divided by s, that is the formula, and here also the same plus minus the same polarity, and then here the v of 0 minus, that is the initial voltage, that is the 10 volt across this capacitor. So 10 divided by s. So now we solved this problem also. So what we had done was the same procedure we are applying in all the equations. On the Laplace transforms, we have few more problems. That is the complex problem. That is the problem number 4. This is the circuit. So here the switch is closing at t equal to 0. This is the switch. Yes. And assuming a circuit at the time of switching, determine the current I for t is equal to greater than 0, and also find the voltage across the inductor. Voltage across the inductor. This is the capacitor and this is the inductor. So you should be able to find in any circuit the current value and also the voltage drop across any device. Maybe if I ask you to find the voltage drop across the capacitor, then you can use the same procedure to find. And if you want to, if you need to find the voltage drop across the inductor, you can also use the same procedure. But the calculations may be a little bit different. So I had given the solution already here. So you can also take a look at them. And also you have to draw the same circuit in S domain. It's I think only 2 more problems. I have more problems. If you want to just let me know. I will give you more circuits to do the analysis.